Hey everybody, this is Larry. This is day 11 of March. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm. I missed March 10th for Mario Day. Oh well. Okay, today's farm coin change. This is very standard farm. Let me know what you think about this farm. Okay, which variation is this though? There are a couple of variations, and usually what you want to do is dynamic programming maybe. But it depends on the constraint, like I said, and it seems like this constraint is that there are at most 12 coins. I don't know, amount is, each coin can be that big, but that's a kind of a weird thing, because you never use a coin that big anyway, because the amount is 10 to the 5th, or sorry, 10 to the 4th, so 10,000. This is going to be a pseudo dynamic programming problem. Yeah, and for not pseudo dynamic program, sorry, pseudo polynomial dynamic programming problem. Did I say the right thing? I don't remember. But yeah, for these ones, I actually have trouble doing it recursively, just historically, because I've done it in the past. So, okay, because I usually do this actually bottoms up, which is not that bad, but I actually now, for the sake of, well, the reason why you want to do it that bottoms up is because the space complexity is it's usually is really tight, so that you could do it that way. But this time I'm going to try to do it top down. It's going to be a little bit new for me because I don't usually do this tops down. So yeah, let's give it a go. So basically, the idea is with these coin change problems is just a minimization problem, right? So then now we can say, let's just sort coins. I don't think that matters that much because it's only 12 coins anyway. But now we can have a function that just goes min change maybe. We have the index. This refers to the coins that we can use left. And then maybe the target left, right? So then if target is equal to 0, then we return 0 because that means that we have 0 left. If target is less than 0, then we return some infinite number. So let's just write inf. I don't know, I've been doing this lately where I just choose infinite to be this big number instead of infinity. With float in Python specifically, I get questions about it. The reason why I do it is sometimes you just want to be able to plus 1 minus 1 without worrying about infinity, and I don't remember off my head how that gets handled. I mean, it's a float, so there are also some weird nuances as well. But yeah, and then now we have, the current coin is coin subindex, so let's just do current coin is equal to coin subindex, and then we have two choices, right? We can either use this coin or don't use this coin, and when we don't use this coin, we want to move on to the next coin, right? So then here we have a best answer, or least maybe, is equal to infinity. We want to return these at the end, so we want to either use this coin, so we have least is equal to min of least, or we go min change of index, because we want to keep on using this coin until I don't know, it doesn't matter, right? And then target minus current coin, right? And then we're done with this coin, and we'll go over why I do it this way in a second. So then when we're done with this coin, we just kind of go this way. And that's pretty much it, I think. We have to cache this. So yeah, hang on. But we'll kind of just play around to see if this is roughly correct, even though we know that this will time out because we don't cache it with respect to top-down memorization. Oh. Of course, we have to keep track of it. N is equal to length of coins, and also, of course, if index is greater than n, or is equal to n, then we return infinity as well, because we ran out of coins and target is not 0, right? Missed one base case, whoopsie daisies. No. Oh, I forgot to add this. So use this coin, we need to add +1, because you get 1 coin, right? So yeah. So this should be good. It looks good. It's going to give us timeout. So yeah, So how I like to do this, and in contests I will usually use an LLU cache because it's quick, we don't have to think about it and so forth. But here I want to make the space complexity explicit, and also to kind of step back a little bit, for dynamic programming stuff, just problems in general, I always analyze the complexity before I solve it. Even though I think on these videos I usually do it the other way around just to be sure, because sometimes I could figure out a better one. But so that I know that this was gonna, or I have a reasonable guess that it was going to be fast enough. There's some nuances with judges which complicates things a little bit, but in general, that's the case. And here, we look at the possible inputs to this, right? Well, index can go from 0 to n, and target can go from 0 to amount, right? I mean, it could be negative, but then we don't need to cache that. Yeah, and that's an O of 1 operation for those cases, obviously. But yeah, so then, and the number of possible inputs is just going to be O of n times amount, right? Yeah, because that's the number of possible inputs, and for each of these inputs, we do O of 1 work, because we do like 3 or 4 operations we call min change, which we can assume to be O of 1 because it's going to be a lookup entry after the first one. So each of these takes O of 1. So total space will be O of n times amount. Yeah, and total time will also be O of n times amount. So this is the O of time, because for each of these inputs we take O of 1 space to capture it. So yeah, but again, we don't cache it yet. So but when we look at all the possible inputs and how to store it, we go, okay, so then now we have a cache function. We can store infinity, for example, just to begin, times amount plus 1 just for whatever, something like this, right? So this is just basically creates a cache of n plus 1 times n amount plus 1 elements, and then we can also just hash cache just as a Boolean version of this, so that we can look it up easier. You can do it in other ways, of course, but I like to do it this way, at least for learning purposes. So I definitely recommend, if you're learning and you want to do interviews, LLU cache is not going to cut it. You have to know how to do this. But yeah, so after these space cases, we check cache. If has cache of index target, then we just return the cache. Whoops. And at the very end, we want to say has cache of index target is equal to true, and then we set the cache is equal to the least amount, right? Cool. Oh, there's so many test cases to put in. Okay, fine. Let's just put in a couple more. So yeah. So that looks sad because we forgot the -1 case. So that's good because, so yeah, so least so that's why we test these things. Glad I didn't get lazy. So if this is bigger than infinity, we return -1. Otherwise, we return least. And the reason why should be obvious. This is just infinity number. Cool. Yeah, let's give it a submit. Cool. Yeah. So I already did the time space complexity. Let me know what you think. Usually I do this, as I said, I usually do this bottoms up, but this time I might get it slightly smaller so I could get the code in one screen. This is very awkward sized, but yeah. So yeah, usually I do this bottoms up, and you can definitely practice bottoms up. And I would also say that I have a video that goes over how to convert from tops down to bottoms up to the space savings portion. And the space saving helps with the time as well, just because you're just spending less time allocating memory as well, which becomes critical in some cases, though not in this one. But yeah, cool. Let me know what you think. This is a standard problem to a degree, though that's why you see me able to solve and explain this so quickly. It's because I've done variation of this many times. So don't be like, if you haven't solved this before, you haven't done it enough times, it's going to take a little bit of time, and that's okay. Just slow down, make sure you understand what every transition of the dynamic programming means and how to do this dynamic programming. This is pseudo polynomial because it depends on the amount, which is not related to the input size directly. So yeah, cool. That's all I have. Yeah, let me know what you think. Stay good, stay cool, stay safe, stay healthy, and to good mental health. I will see you tomorrow. Bye bye.